Welcome back. This is Chapter 2, Section 2, entitled Bar Graphs and Line Graphs. Let's start with vocabulary. A graph is a visual way to display data. A bar graph is used to compare quantities. The scale of a graph is written on the vertical axis of a bar or line graph. Scales are separated into equal parts called intervals, and the blanks are written on horizontal axis of a bar and line graph. The categories are written on the horizontal. The frequency is the number of times an item occurs, and then a line graph is used to show how a set of data changes over a period of time. And you can add in here if you want, say that the time is the horizontal axis. All right, so there was a bunch of information here. Basically what it entails is you have a graph like this. This is horizontal. This is vertical. All right, you have a scale, so each of these things should have a equal scale. Depending on how you set this up, you know, time or if it's a line graph, you put time here. If it's a bar graph, you put the different categories. And then up here is always the frequency or the number of times it is. So, make a bar graph of the data. Compare the time it takes for a rabbit to be born to the time it takes for a camel to be born. So, step 1, decide on a scale and interval. The data include numbers from 31 to 406. So a scale from 0 to 500 in an interval of 50 is reasonable. You could have gone from 0 to 450. Oh, I'm not sorry, not an interval of 50. I'm sorry, an interval of 100. You could do an interval of 50. You could do an interval of 10. You can make these numbers. Step 1 should look different for all. And you don't even actually have to start at 0. You could have started at 30 and gone up to 410 and then done intervals of 10, 20, 30, however much you wanted. For us, though, this scale here goes from 0 to 500 with an interval of 100. Step 2, label the horizontal and vertical axes. So remember, the vertical axis, the scale of a graph is written on the vertical axis. The categories are written on the horizontal. So the categories, the animals, are written over here. And then in other information, the gestational period should be here. So step 4, label the graph with a title. Now, it takes about blank times, so now we actually have to do it. So let's talk about squirrels. It's going to be hard for me to draw. Actually, I might be able to use some boxes up here. All right, so a squirrel is 44, so it's about half. A rabbit is about 31, so it's less than a squirrel. A puma is just about 100, so it's right there. A moose is 240. So it's all the way now almost up to here. So that's for a moose. A kangaroo is 36. Well, that's not quite right. And a camel is 406. So you can see 406 is a really long time for gestational periods. All the way up here. Now, I'm going to rearrange this so it fits better on my graph. So there's camel, there's kangaroo, there's moose, puma, rabbit. All right, so the question is, we have to compare, it says to compare the time it takes for a rabbit compared to a camel. So looking at the graph, here's a rabbit, here's a camel. And I look at these graphs and just say, all right, well, that's about 2 times, 3, 4 times, 5, 6 times, 7, 8, almost 8 times as many days for a camel to be born as it does for a rabbit. Now, let's think about humans. It's about 9 months. And there's about 30 days per month. So for a human, it's about 270 days of gestational period. So if you look at this, a rabbit takes 31 days. So a rabbit is pregnant for 31 total days. All right, let's look at this. Make a bar graph of the data. Compare the number of customers at the restaurant on Monday to the number of customers on Saturday. I'm going to pause the video and draw the graph here so that it can look nice for you. All right, so I've set up part of it. The categories go here. The frequency goes there. We need to set up Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. Okay, so you can see we got to make this a little longer. We need to come up with some bar graphs now. So, well, let's look at the scale. Now, you can make whatever scale you really want, but if you look at these numbers, the smallest number is 50, the largest number is 150. So, to make it easier for ourselves, let's start at 0, make that 50, 100, 150. You could do it this way. You could also make the scale go by 25. So this could be 25, 50, 75, 100, 125, 150. And just for a good measure, we're going to do 175 as well. That's probably better because it'll spread your graph out a little bit. Now let's draw, we're doing a bar graph. So now we simply take a look at, we make a bar. So on Sunday it is 120. So on Sunday it's all the way almost to 125. On Monday it's only 50. On Tuesday it goes up to 62, so it's a little bit more than Monday. On Wednesday, 71. It's getting higher again. On Thursday, 84. On Friday, 112. And then on Sunday, all the way up to 150. So the question asks us to compare at the restaurant on Monday, compare to the numbers on Saturday. So Monday is about 50. Saturday is about 150. So you could say that it's 3 times more on Saturday. That's how this one gets set up. All right, so a line graph is fairly similar, except you're not drawing bars this time. We need to make a line graph of the data to the right, then describe the change from 60 to 95. So for a line graph, the first thing you need to do is to, let's see here, decide on the blank. So you're going to decide on the scale. So you're going to look at the data. 61 is the smallest, 100 is the biggest. So the scale could be a lot of different things. If you look down here, the scale, they made um, 0 to 120, and the interval is 20. So they decided to go from 0 to 120. You could have gone from 40 to 120 and made the scale 20. You can make the scale and the intervals whatever you want as long as it makes sense. You then label the horizontal and vertical axis. Notice that here is time, like I mentioned before. So once you have that, you draw and connect the points for each year. Each point shows billion gallons of water consumed per day. So starting in 1960, it's 61. So you put a little dot. 1965, it's 77. In 70, it's 87. In 75, it's 96. In 80, it's exactly 100. 85, it's back down a little bit. It stays kind of stagnant in 90. And then 1995, it's 100 again. So we drew those points, and now we connect the points of each year. Get a blue pen here. And do my best at connecting the dots. There you go. And then you should always label the graph with a title. So the question is, water consumption between increased from 96 to 99 with a slight dip between 80 and 95. So you are comparing, or you describe the change. You can do it just by saying what you see. It increased from 1960 to 1980, had a small drop, and then started to go back up again. So that's how you can describe it. All right, it looks like we're getting close to being done. Oops. There you go. So make a line graph of the data below. All right, well, let's look at this data. And the graph's already made for us. So you should say that the scale for the vertical is 0 to 30 with the interval of 5. And then the times the horizontal. So 1997, 23, 1998, 20, 1999, 18, 2000, 18, 2001, it's 17, 2002, it's 24. So make a line graph of the data. We plotted the points already. Now connect with super straight lines like I just did. And it says to describe. So you would describe this problem by saying there is a decline. I could even say slow decline from 1997 to 2001, and then spikes, meaning goes up quickly from 2001 to 2002. There you go. That is comparing those. So, video is not too long. It's a little longer than you're used to, but these will be the practice problems we do in class. Make sure you do the check your understandings. Good luck.